Our next panelist is Spacek from Fame, who will be talking about Venus and Mars and hunting for life. Venus might be interesting, but Mars is urgent.
Exactly. Thank you, Paul. So my name is Spacek, and this talk will change your life. From now on, when you look on a night sky and see Venus there, you will think about beer. Sorry about that. Yeah. So the interesting thing about the Venus, it's its atmosphere and the cloud which surrounds it all. And people were wondering why the Venus is yellow for quite a long time. Many great scientists, including Paul Rimmer and Janusz Petkowski, were puzzling about this. And in UV, we can see that the Venus is actually quite very absorbing. We can see those dark streaks. So how I got here, why I'm talking about Venus now, that's because a breakthrough diverted me from research of Mars. I wanted to study life on Mars, and so I contacted Pete Klupar if a breakthrough would be interested in funding my research. And Pete said, ALF is a very cool idea. I will talk about ALF later, but we are interested in Venus. So that's why I was working on Venus for a while. And so in 2021, this is a student I had for 2 months from the funding. And within 2 months, we together found that basically all organics you put in concentrated sulfuric acid turn to fluorescent material, which was very interesting. And I developed first proposal of a organic carbon cycle in Venus atmosphere. And you can find that in that paper. And so from the original mission to which was called Life Finder, I have helped to steer it a little bit more to search for organic carbon cycle, which is now going to fly to Venus. And then later on, we refined my original results, and we showed how from simple chemistry, which is generating from photochemistry, you can get to large organic molecules. And so you can read that in this paper. And we showed that with Paul Rimmer, helped us with a quantitative model. And we show how much organic carbon we can expect in the clouds of Venus. Before I go further and explain why you think about the beer a little bit more, look on this picture. We have very dark water in the river, which, however, when it breaks down to smaller droplets, appears brighter and brighter. Finally, the fine mist, even though it's composed of the dark liquid, appears white. The same effect we have with the beer, right? The beer, regardless if it's black or yellow, has a foam which is quite white. So that's the important part. So beer Lambert law. We have Mr. August Beer and Lambert. They showed that from the amount of light which is absorbed by liquid, we can assume the absorbance of the solutes. And so the important part is how you get from this back to the liquid, right? And so the question, before we ask why is Venus yellow, we should instead know how dark is the liquid that composes the clouds, right? That's the better question, because when you are ordering beer, you are not saying, hey, I want beer with white foam. You say you want dark or light beer. And so the smaller the particles, the more is the effect of scattering pronouns. And this direct comparison I made, it's not very predictive. It's not very quantitative. We can just say it's quite dark. So we don't know how dark it is. Is it like a white wine or tar? But I met this great scientist, Yeon Lee, who helped me answer this question. and she used radiative transfer scattering model to produce this result. For those of you who know something about Venus clouds, this is not surprising shape. What's surprising is the units on this axis. Again, Mr. Beer tells us that absorbance is logarithmic, which means that when you have absorbance 3000, you would have about 3000 zeros before you get a percent. So basically no light passes through. Even if you have absorbance around 100, that's still absorbing almost virtually all light. So another important thing, we can get the concentration of stuff if we assume the absorption coefficient. And so here I have blood for the science. I compared absorption of my blood to absorption of the model's Venus absorber. And you can see that at its maximum, it absorbs about 3 times more light than my blood. And it absorbs basically all this blue and this, how you call this, color. And so when you compare it to absorbers we know from Earth, very efficient absorbers like chlorophyll or heme, you would still need about 1 to 10% of these absorbers to explain such a high level of absorbance, which is very surprising. Also, we showed that previously favored iron chloride is not sufficient even if it's 100% concentrated. Also super interesting. And so we would need about 30 grams of highly absorbing material in the droplets to explain the absorption level. We can find some absorbers which match this, but I'm not saying that this chlorophyll from this bacteria is the one. I'm just saying that it's something similar like this. And what's important, it's not random tar-like mixture which would absorb throughout the entire spectrum, like we showed before. So Janusz and Ion were on my beer model from the start. With Paul, I had to do some convincing. And we are now preparing a paper. Hopefully we will submit it next week in arXiv and in astrobiology. So this was super interesting. Now you will think about beer all the time when you see Venus. But I think Venus is not urgent. I still think that we need to look on Mars, because regardless what we find in Venus clouds, Venusians are not coming to, eat us or something. So this is how I see astrobiology. Now, these are astrobiologists throughout today, yesterday, and for the rest of the day, everybody will be talking about exoplanets, Venus, and ocean worlds, Titan, right? Because they are huge, fun, and now my results just put a bow on Venus, so made it even more interesting. But we have the mama bear over here, which is a Martian biosphere, and we need to be studying that. So now to the Mars. So unfortunately, I will not have time to get into details, which I really like. But the more we know about Mars, the more we are convinced that life can be on its surface. So you will have to trust the opinion of experts. Most people in 2019 on this conference were convinced that life on Mars is likely, since that we have many new results which show that it's very likely. And so people were calling for search for life on Mars for, well, all the time, but they are usually not very heard, right? This was 2015, nearly 40 years since Viking. Are we ready for life detection? Answer was yes. Only thing that changed, now it's 50 years since Viking. And so when NASA tells us we've been looking for life on Mars, that's just for public. We, interested people, we understand that they might not overlook a moose. The reality is that none of the instruments currently on Mars would find life as we expect to be there. So the sensitivity of instruments is not enough to detect life in Atacama Desert. So if we took the instruments which are currently on Mars or plan to be sent to Mars, they would overlook, find this paper. I don't have time to get into details. So Mars is very urgent because we are sending humans there, and it's not just NASA, it's also Chinese agency SpaceX. And from this timeline of Chinese space agency, we have a Venus atmosphere sample return and Mars science station planned in 30s. So whether we like it or not, politics dictates what we need to study, and sometimes you have more urgent things, not just what you are interested in. This is a president of Mars Society, Robert Zubrin. This is my boss, Stephen Banner, and together we wrote this article 3 years ago. And so in there, Robert Zubrin argues that Martian life is not dangerous because Martian life is adapted to live on Mars. So just like sharks would not be dominant species in African savanna, Martian life would not be dangerous on Earth. Well, to which I argue, what about rabbits in Australia or rats in New Zealand? We have many examples where more advanced species overrun, like generalists, the generalists, other way around, it's the specialist in a local area. So Stephen, always pragmatic, which position is more likely to get us more funding? So we need to have some risk mitigation insurance policy, right? So you have a cost premium, cost of disaster, and times probability. This is not my specialty, but for example, NASA with the sample return, the planetary protection put a extra cost about maybe 10 billion, in order of billions to $10 billion. Notice that Mars sample return was not cancelled. So now we have there are no current plans for planetary protection for going back from Mars. Nobody's doing anything about it. So now I think you understand that search for life on Mars, that's currently living on Mars, is the only space endeavor that cannot wait. And the only way how to deal with this is to find life on Mars before we send humans there. And to succeed, we need to have ability to find unknown life forms with unknown biology and unknown ecology that will likely be very sparse because low energy environment. And we need to do it very fast. Compared to previous Mars missions, which took 20 years from planning to execution, we need to do it very fast. So it sounds hard, but we already have a solution. I believe that within $10 million investment, we can provide ready instruments to achieve all of this. So 10 million sounds a lot. That's 10 million evil guys. Or I mean, it's 10. You know what I want to say. So the solution we were proposing for a while now through Agnostic Life Finding Association is to make our instrument ALF. ALF, what you need to know is that there's a Martian water cycle. As Mars wobbles, the ice is deposited in mid-latitudes in layers of ice and dust, and that dust would contain samples brought from the entire planet. So if during the high obliquity period, when Mars is much warmer, much wetter on the surface, if life was anywhere on the surface, it would be deposited in that ice, from which we can find it. So that's my lasagna ice hypothesis. Life was deposited in this ice, and from what we know about life on Earth, it's detectable in there for millions of years which is enough to get back to those very high obliquity periods. And we also know that there are plans to mine Mars water with SpaceX plans to generate propellants, to generate ISRU water. And so we are currently talking to Blue Origin. Well, it was Honeybee, now it's Blue Origin. They are making these rod wells, machines to drill into ice, pump hot water down, and to extract the water. And now another ingredient for our instrument is polyelectrolyte theory of the gene. Basically, all molecules that are necessary for life. We are looking for molecules that are necessary for life, not molecules that may be produced by life. I will need to fast forward in here. So we avoid false positives and false negatives. And we are using this instrument, right? Okay, so the instrument is based on a membrane electrodialysis, where we are separating polyelectrolytes, which were first released from a compartment using sonicator. Negatively charged polyanions end up in this channel. Positively charged polycations end up in this channel. And so we had funding for this from NIAC. Now we are hoping for a NIAC phase 2 funding. We should know within a couple of days whether we were funded on that or not. And this is the instrument we built with the first phase. It doesn't look very glamorous, but it works. We have the second instrument in making. It's actually already made, and we will start testing it soon. And we are ready for that 2028 deadline. So far, we are on a timeline if we get some funding. So, and this is called to all astrobiologists. We need all hands on deck. Whoever can switch fields, work on Mars life. Now, there's a little bit of personal responsibility because there's maybe a couple hundred people in the world who can do this to help us find life on Mars. So shout out to Chris, who's doing PR for Alpha Mars, and to Gabi Rizal, who works with us, and I hope she will get well soon and yes, join our team. And I have 30 seconds. Do I have 30 seconds left? Okay, so bonus slides. Back to Venus. So why wasn't the beer model of Venus discovered before? Because the physics I presented was not new. So I think it's because beer in a United States looks like this. So there was not enough studying material to recognize that scattering affects properties of liquids. And the second part, I think that astronomers who were favoring iron chloride never tried to put iron chloride in sulfuric acid because it immediately turns into this sulfate, which is colorless precipitate. So on top of it not being absorbent enough when it's dissolved, and that's something to talk about during the discussion. So thank you.